Okay, which option would you take? Option one, you're going to flick this coin here. You either get heads or tails. And then you roll a die. Okay, option one is getting a head and an even number. This and is very important. It basically means you have to get a head and an even number. Even number, and means both. This and is actually quite important. It's not like or, where you get heads or even. Well, there is a difference between and an or. Well, if it's an and, it means, well, this, let's say you get a head and a 3 here. Well, this is a bad outcome because when I say and, it means you've got to get this and an even. Okay, but with the second one, it says or. Well, if you get a head or a 3, then this would be a good outcome. Well, there's a big difference between and an or. Okay, but in this case, is an and. It means this has to be satisfied and this has to be satisfied. So basically, and means this and this. Okay, so you got to get a head and an even. Okay, that's option one. Option two, getting the same color. So here you've got purple here, white here. Here you've got purple, white, white. So with this spinner here, you're going to spin it, and it could land on any of the 4 equally. Here, with this triangular spinner, if you spin it, it could land on one of the 3 equally. Okay, so option 2, getting the same color. So it could be purple. It must be purple. Then that would be a good outcome. If you get a white and a purple, that's a bad outcome. Or purple and white, that's a bad outcome. Okay, so which is a better option? Which option's easier to get? So press pause and have a go. So again, draw a map of all the possible things that could happen here. It turns out the table is a good representation of this. So hang on, 1, 2, 3, 4, 5. So this we are trying to represent the die here. So it would be 1, 2, 3, 4, 5, 6. Okay, now we are going to represent the coin. It could either be a head or it could be a tail. Okay, so now we pretty much have a map of all the possible things that could happen. Now, our condition, we have to get a head and an even number. So a head, so pretty much tail would be all bad outcomes at the bottom. So this would be good. This would be good. This would be good. Okay, out of the possible 12 outcomes. So probability of a head and, or let's just use this symbol. Just accept this symbol as an and. Okay, don't worry about it too much. So a head and an even. So even. Okay, equals. So probability of getting a head and an even would be 3 out of the possible. Well, you got 6 here and 6 here, so that would be, yeah, that would be 12. So the probability of that is 3 over 12. Okay, let's look at option 2. Same color. So same color would be, let's represent this one first. That's a row here. Hang on. So we could have purple. Okay, white, purple. White. Okay. With now we're going to represent the spinner. There are 3 outcomes. So 1, 2, and then extend these. So with the spinner, we could have. It doesn't matter about the order. We could have purple, white, purple. Okay, because there are 3 outcomes here. So basically, this purple is represented by this. This white here is represented by this here. And this purple here is represented by this here, this purple here, this purple here, white, white, this white here, white here. So we pretty much have a map of all the possible things that could happen. Now it's just identifying good outcomes for us. This is good, purple and a purple. This is bad because we've got white and a purple. Purple and a purple, that's good. White and a purple, that's bad. White and a purple, that's bad. White and a white, that's good. White and a purple, bad. White and a white, that's good. Purple and a purple, that's good. White and a purple, that's bad. Purple and a purple, that's good. White and a purple, that's bad. Okay, so probability of, let's say same color, okay, same, equals, well, 1, 2, 3, 4, 5, 6. So 6 out of, well, we've got 4 here, 4 times 3, 4 times 3 here would be 12. Okay, so actually the probability of same is 0.5. If you get 6 divided by 12, it's actually 0.5. So it's quite strange. Given this situation here, if you spin this thing and then spin this, the probability of you getting the same color is a half, or 0.5. Okay. Now let's look at this. This here is going to be 1/4. This is the same as 0.25. Get a calculator if you don't believe me. 3 divided by 12 would be 0.25. So if you look at this here, this is like 25%. This is like 50%, pretty much. So it's much easier to get the same color. So option 2, again, option 2 is easier to get. So when you spin this, the probability of you getting the same color is 0.5. Okay.